Hi, everybody. Thank you so much for joining today's session on custom metrics with Datadog and NoBS, a premier Datadog partner. Here's what's about to happen. We have roughly 40 minutes of upfront content and a live demo, and then we'll wrap up with some Q&A. So you can drop any questions that you have throughout today's session in the Q&A at the bottom of your screen. We'll be sure to get to as many as we can. Today's session is being recorded, so you'll have access to the entire discussion and the slideware later on. So with that, let's roll to Kevin and Nick for some intros and all the good stuff you came here for.
Cool. Thanks, Jess. How's it going, everyone? Kevin Goldschman, Partner Solutions Engineer here at Datadog. I've been with Datadog for just under 4 years now. First couple of years, I was on the tech support side where I specialized in tickets that dealt with custom metrics, cost related to custom metrics. So this is kind of my bread and butter. I switched to the partner side about 2 years ago, where I kind of work anything technical with our partners. So NoBS being my favorite partner here. So yeah, from that, I'll pass it on to Nick.
Thanks, Kevin. My name is Nick Pacelio. I'm the principal engineer over at NoBS. Been a Datadog user for a very long time at this point. And NoBS, as Jess mentioned, we're a premier partner with Datadog. We focus 100% on Datadog implementations and everything that goes into it, including cloud work, automation, code instrumentation, troubleshooting, you name it. If it's related to Datadog, we do it. Something that we see very commonly is issues with custom metrics in people's accounts. There's often good reason for this. It's well-intentioned to make sure that we have the data that we need to operate and have a good understanding of our business and our health. However, it's possible that this goes wrong pretty quickly. As Kevin mentioned, he probably wouldn't be here with us today if it wasn't for custom metrics. So in order to understand how to get this right and to not do things wrong, we're going to start right at the beginning, and we're going to talk about what a metric actually is. Let's develop a full understanding of this before we go into the custom side of things. So when we talk about the 3 pillars of observability, we typically talk about metrics, logs, and traces, often referred to in that order. Metrics are really the bread and butter of observability, and they're typically the first thing that anyone is going to interact with in Datadog. You know, it has you set up an agent, and right off the bat with that agent installed, you've got access to system level metrics, and you can start playing with them to see how the tool works. So metrics are basically going to be your first entry point into Datadog, and ultimately one of the most important throughout the whole lifecycle of your usage of the tool. A metric is quite simply just a numerical value over time that can really measure just about anything. So we've got things like system CPU utilization, we've got number of requests, orders placed, here, there, and everything in between. But we can also transform these metrics using various functions, do arbitrary arithmetic on them, and present them in many, many ways more than just this regular old time series line chart. Datadog gives us access to 5 primary types of metrics. So what we have at the bottom of the screen here, we have an example data set of just 1s, 2s, and 3s, and we can use these in a pretty simple way to reference how these metrics work and why we might use them. To start off simply, a count metric is just the total number of occurrences in one interval. So if we use our example data set down here, we're just going to add those numbers up together, and that's our count. That would be a value of 15. Counts are going to be useful for things like how many requests have hit a web server, how many orders were placed, and other sorts of event type information that you would need to understand the number of occurrences of. A rate is similar to a count, with the main difference being that instead of summing the numbers, they're actually divided by the collection interval. So the collection interval in this case, in our example, is 10 seconds. So we collect data for 10 seconds and then we flush it out. So in this case, that count value of 15 is divided by 10 for 1.5 per second. A gauge is used for point-in-time measurements, which is going to represent the most recent value of the collection interval. So in this case, that's going to be 3. That is the most recently collected point in our interval, and that's what it's going to represent. You can think of it kind of like a fuel gauge. It goes up and down as you add gas or utilize gas. We have those point-in-time references where the dial is always representative of what's in there at the most recent time. A histogram is a bit of a combination of these metrics and by default provides 5 metrics to use as a statistical distribution. So the average, of course, is going to be the sum of all values divided by the number of values in the set. In this case, it's going to be 1.88. Account here, if we show it as a rate, would be 1.5. You can switch between count and rate with account metrics, so pretty handy there. The median given to us by a histogram is simply the middle number of a set of data. In this case, it's going to be 2. And then we also have the P95 and the max. The P95, of course, being the 95th percentile of data, which in this case, with our very small data set here, it's going to be the same as the max, which is going to be 3. So histograms are great when you need a few different types of metrics. If we want to know, basically have a combination of a gauge, a count, and a rate, the middle ground, and then our upper tier, a histogram is a great solution. And then a distribution is effectively the raw set of data. It's sent to Datadog as such, which allows you to do arbitrary percentile calculations. So if you've ever wondered what your 82nd percentile was, well, you could find that out. I don't know why you would, but yeah, you could. Let's talk a little bit about tagging. So back in the days, if you're old like me, and we had things like StatsD, metrics were flat and a 1-to-1 series where the numerical values were just a single series under a single metric name. The name of the metric was often dot delimited, and that presented a kind of logical hierarchy, if you did it correctly, that directly described what the metric was representing. So in this case, our top level namespace is going to be apps. Within those apps, we have our customer API. It's running in production out of the Boston data center. And then our actual measurement is going to be the count of 200 level responses. So as we can see, it's pretty clear, it's pretty verbose. We know exactly what we're getting, but this can come with a little bit of a headache. Let's say we have 1,000 services under apps that run in production, dev, and QA. We're running multiple data centers, and then we have the bevy of HTTP response codes that you could, imagine 200s, 300s, 400s, 500s, 429s, all that good stuff. So the reason that this makes life difficult is that since these are 1-to-1, you had to craft your dashboards to reflect this appropriately. So if you have 100 metrics that you need to represent, you're writing 100 queries, and that's just one panel. So also introduces a lot of room for human error. If the metric namespace is not correct, or we simply just missed a metric, you might not be accurately reflecting your data. So what we do in Datadog instead is we utilize tags. So the metric name is a bit more representative of the content of the metrics, where the tags represent what was formerly the namespace. So a metric becomes multi-dimensional. This allows us to graph one metric and then split it by these tags. So what we would actually wind up with in Datadog is, instead of metric that would be named request count or apps.request.count or something to that effect, something very simple. But then underneath, we would have a tag for service of customer API, end of production, data center of Boston, and status code of 200. What this then allows us to do is we simply put apps.request.count up in our query widget. We split it, we filter it to end of production, we split it by data center and status code, and suddenly what was formerly 100 queries is now 4 clicks into one query that presents the same number of data points without any confusion as to what's actually being shown. Now that we've talked about what a metric is, let's get into our main topic, which is going to be custom metrics. It's exactly what they sound like. Instead of metrics that are created by one of the 1,000 plus at this point out of the box integrations that come with Datadog, these are metrics that are created by users of Datadog. So custom metrics wind up being submitted in a number of ways. If you utilize dog_statsd within your code to instrument function level or business logic or anything within custom code or scripting, dog_statsd is all custom metrics. Just like a custom agent check would be. If you write an agent check to run against proprietary software or an API that exports data that's otherwise not supported or is custom to your workplace, those wind up being custom metrics. Marketplace integrations provided by Datadog also wind up being custom metrics. These are things that other partners provide on the marketplace to allow you to license them for checks that aren't necessarily natively supported by Datadog, but partners have created. But these do also create custom metrics. It's also worth noting that some included Datadog integrations can submit custom metrics, and we'll talk about that in just a second. And lastly, we can also create custom metrics within the Datadog UI based off of other telemetry like logs, RUM, and APM data. So like I just mentioned, the overwhelming majority of metrics from Datadog integrations are included and are not custom. Some integrations can create custom metrics, and some are always custom metrics. So examples of integrations that can create custom metrics are any database integration, JMX-based integrations like JVM, Solr, Tomcat, Elasticsearch, and then the SNMP integration. These are all super helpful for a number of reasons, but we do have to be careful with them. Database integrations allow you to craft custom queries and present metrics based on business data that's present in your database or other engineering data. It's not uncommon to see organizations track the statuses of regularly scheduled jobs in a database, or have a table that acts like a queue. Or what if we just want to count the number of orders that have been placed in the past hour and we don't want to do the work of instrumenting our application when we can just run a query for it? We're able to run those queries programmatically through the agent and produce that data back out as metrics with tags into Datadog. We could also track how many jobs have failed, what the average duration of a job is, what the oldest item in a database table queue is, how many items are in there. If you can think about it and write the query for it, you can turn it into data points through that. JMX type checks allow you to create a configuration that pulls in arbitrary metrics exposed by the JVM. So if you've instrumented your application itself to just expose metrics out to the JVM, you can pull those in. Or if there's other metrics that you want to pull in from one of the integrations that's already provided, like Solr or Tomcat, you can pull those in as well. The SNMP integration allows for the creation of custom device profiles or for the addition of metrics to existing profiles. So everything is pretty well covered in terms of your main device vendors like Cisco and Aruba and everything like that. However, it's not going to be the full content of all the data that's present in SNMP. So if there's a metric that you need that's not supported, you can extend the profiles to collect that. Or if there's a device that is not supported for whatever reason, maybe you've got an old switch that you dug out of your basement from the 80s, but it presents metrics. Yeah, you can create a profile for that too. Some integrations are always custom. Kevin, when I bring up open metrics, based on your experience in the past, what are your thoughts here?
Open metrics tend to scare me. A lot of my experience in the TSE world ended up with high costs, high unexpected costs with open metrics, and a lot of time spent digging into those tickets.
Oh yeah. So this is going to get its own slide, and we're going to come back to that. So hold that thought. Now, the good news about integrations like this, as we can see on the screen here, is there is a warning directly at the top of the Datadog integration documentation page that will tell you that all metrics received by this are considered custom metrics. The other good thing is that there is a limitation on the integration itself. I believe it will only collect it's a maximum of 300 metrics, I believe. However, you can change that. And that's typically where things go wrong. They try to put in a safeguard. So the max you can collect is 300, but you can change that to whatever number you want. And that's where the danger lies. More on that in a second. All right. So we know what metrics are. We know what's custom. We know what's not. Let's talk about how they're billed. When we create custom metrics, this is the most serious consideration to make next to how they're counted, which is actually the next slide. The reason that we're putting on this webinar is because this is a very, very common issue. Like I mentioned at the beginning, creating custom metrics is an extremely important part of any observability tool or any custom instrumented applications already, or if you're using OpenTelemetry and have that instrumentation done. There's a lot of extremely valuable data. This webinar is not to say don't do this. It's to make sure that we're doing it appropriately and understand the impact and how we should go about this. So it's not to say don't make custom metrics. It's just to say let's be mindful of them. But let's talk about how they're built. Knowing how they're built can help. And when we talk about this, there's kind of two different levels of it. Depending on your plan, whether pro or enterprise, you will have 100 or 200 custom metrics allotted to the account, respectively, which will bank across the account. So we have the ability to present custom metrics from the UI or from any other source. And we use host A and host B as the example down the bottom here. But these custom metrics don't have to come from hosts. They can come from Lambda functions. They can come from any other number of places. This is just for sake of example. So that is to also say they're not allocated to a specific host. So we have this diagram here. If we have two hosts and we're on the pro plan, we get 100 metrics each. Host A and host B can each use 100. Just like host A and host B host A can use 10 and host B can use 190. But if we go over this allocation, we have 110 metrics used on host A and 200 metrics used on host B. We are now 110 metrics over our limit. Custom metrics by default are billed in units of 100 when over the allotment, with the price being based on your contract. So, speak with your sales rep if you have a strong need for a significant amount of custom metrics. But just for sake of discussion here, the list price is $5 per 100. And once we talk about how they're counted, you can see how this can become pretty expensive pretty quickly. So how are they counted? So we talked about billing first. We probably could have flip-flopped these, but it works both ways. So custom metrics are based on the unique tag and value combinations. So if we use the diagram that's provided here, we can take a simple example and do some basic calculations. We have 4 distinct combinations present here. Host A has endpoint X with status of 200. Host B also has endpoint X with status of 200. Host B also has a status of 400 for endpoint X, and host B has endpoint Y with a status of 200. This is clearly just 4 metrics based on these unique combinations. So your count, rate, and gauge is going to present 4 metrics if this is how we create them here. Histograms, like we talked about earlier, also present the average, count, median, P95, and max, which is inherently 5 metrics. So if we have 4 unique combinations times 5 metrics, that is 20 metrics. Distributions are when things get a little tricky here. You can configure through the agent what percentiles are collected for distribution metrics. So even though we have a very, very simple example here where it's just 4 distinct metrics, it's extremely difficult to say, even with that simple example, exactly how many metrics that could be in a distribution. Because if you collect 1 percentile, it may be 1 additional metric. If you decide to collect significantly granular, crazy percentiles, it could be n number of metrics. So the concept of counting these metrics now brings us to the most important slide in this presentation. This is where we talk about how things can start going horribly wrong. And speaking of how things went horribly wrong, this is maybe also one of the worst puns that I have personally ever written. This is the cardinality sins. The cardinal sins. Come on, I shouldn't have to explain it. I did. I'm making myself cringe even further. I'm going to carry on. Sorry, Kevin. So cardinality is, of course, the number of unique elements in a set of data, where cardinality always has the possibility to be infinite. Creating tags based off of data of infinite cardinality is by far one of the worst things that you can do when creating custom metrics. Kevin, when you've seen some of these issues with custom metrics, when we look at what's on the screen, even though we haven't talked about the rest yet, what is this most significant issue that you've seen?
Yeah, typically the unbound tagging. So things that I'm seeing on this is IP address, request IDs, things that can essentially be infinite. That's kind of where the danger starts to creep in.
Oh yeah. So because things are infinite, that generally means that these values are never going to be the same. Items like a GUID, which is globally unique identifier, that in and of itself says those numbers will never be the same. Timestamps are also typically unlimited. Well, they are limited cardinality, but they may have some overlap. If you had a request hit at the same exact microsecond, then you could have duplicates of those. But when we look at things that are always unique like this in one way or another, when we talk about the distinct number of value combinations across tags, every single one of these series winds up being unique. So every single request winds up adding an additional custom metric. So infinite cardinality is the worst thing that we can create a tag off of. The other thing is that these are probably going to be useless. Once Kevin busts open the demo in a little bit, we'll see exactly why that is. But the short story is that you basically wind up just getting a bunch of polka dots on a graph, and it doesn't really mean anything if you were to split it by the GUID or timestamp. We also have issues with high cardinality. It's not as bad as infinite cardinality, and high cardinality I would describe as things that have bounds but can have many values. So things like customer IDs can have extremely high cardinality, but it's also based on how many customers you have and how many are active in a given time. So if you only have 10 customers and there's only 1 active a month, it's probably not an issue. If you have millions of customers and hundreds of thousands are active at any given time, that could be extremely high cardinality right off the bat, even though technically there are bounds, except those bounds continue to grow, hopefully, as your business grows. IP addresses also have bounds. There are a finite amount of IP addresses for IPv4 and, a finite amount for IPv6, although that bound is exponentially higher than IPv4. So, it's definitely tricky there. And then product SKUs is another one. It's definitely a valid use case to track how many of what particular pair of shoes you've sold over time. However, if you only have 10 products, you're probably fine. If you have 10 million, it's probably going to be a bad time. Something else that we see pretty commonly is it happens a lot during migration processes where people move from a platform that is log driven like Splunk or Elasticsearch, where they're presenting metrics, into a platform that's more metric driven, like Datadog. So people will go and they had logs that originally had extra facets that included timers and everything like that. And that's perfectly fine, except the thought process doesn't necessarily change when they convert that to be DogStatsD. So what we wind up with is, instead of having those be individual metrics, we have tags that include numeric values that should just be metrics themselves. So this is like a little bit of an abstract idea, but I've definitely seen metrics with tags for something like value, where the value is a number. So for splitting by that value, it's not going to mean much, and we should be able to chart that independently already. And then the last cardinality sin, is open metrics, and this gets its own slide. And now, if any of you are faint of heart, squeamish, have any reason, a low blood sugar, anything, this next slide contains some graphic content, which may not be suitable for all audiences. Viewer discretion is advised. Kevin, when you see this, if you can stop shaking for a moment, what is this to you?
This is going to be back to that high unexpected cost, and I'm sure I came across this exact screenshot several times as the TSE, but you'll see in that maybe third line with the asterisk, that's what scares me.
Yes, this 7 lines of configuration, 8 if you count the comment, I guess, is probably one of the single worst things that you can do with a Datadog integration in regards to custom metrics. So what this is doing is, we're just pointing to our SumHost1234 as a Prometheus endpoint, but then we're telling it to do a regex-based collection. .star means everything. We're also saying to collect histogram buckets. So if you have a Prometheus exporter that has like those LE equals type labels to indicate different histograms, we're going to collect those all as histograms. And then, just to double whammy things, we're going to tell Datadog to collect those histogram buckets as distributions. So if you have a large number of different histogram breakdowns within your exporter, we are now multiplying our metrics exponentially. The other thing here is that if you're running this in Kubernetes, which Prometheus exporters can definitely run elsewhere, however, they are most commonly found in Kubernetes. Since the agent will collect these and the agent metrics inherit all of the other tags, you're also getting a significant multiplier based on the node, the region, the instance type, like everything else that's attached to metrics that come out of Kubernetes. So this can get out of hand very, very quickly. And this is the primary cause, in my experience, of metric inflation, just in my personal experience. So why is this so scary? If your exporter looks like this, really not an issue, right? We're not trying to scare you. We just want to make sure that this is done correctly. We can kind of basically compare this back to the diagram that we had a few minutes ago with 4 metrics being exposed. We have the checkout service and auth service all running in prod with 1 route each, 2 status codes each. And then we have a worker and a queue. And, this is not a ton of metrics. Ultimately, this is 6 metrics. So this is fine. This is, if you were to collect this and this is all your exporter ever put out, you're probably in just fine shape. Now, that also said, if you were tracing this application, you would not need to collect the HTTP requests total metric. You would already have that provided to you by the trace metrics. And that's another thing that Kevin's going to talk through as well. Like, do we need to collect custom metrics, or do we have other telemetry available? But what if things start to look like this? And this is where things can get a little scary. We have a histogram presented with the metrics that end in bucket. So we've got 3 different bounds, which would also be converted to a distribution metric. So those top 3 lines alone have submitted at least double or triple what our last slide alone already sent. We then also have, the other kind of sum and count metrics that are associated with that. But then we look down to active sessions, and this has user ID present in it. And like I said earlier, if you only have these 5 customers, again, that's probably fine. However, if you tack on a few zeros to that 5 and you have a lot of them active at any given point, you've now put a significant multiplier on your metric. And then things down the bottom are where things go really off the rails. We have the service of checkout in production, but then in our route, we have the actual order number in the route. So it's not just obfuscated as order ID, it is the actual order ID. We then also have the request ID present, which is going to be, a unique identifier, and the user ID. So every single metric that is collected from this exporter is now going to be unique, and we've run into our issue with infinite cardinality. So never fear, there are ways to still collect this data in a way that is perfectly sane. One of the ways to recover from this while using open metrics is you can still use .star. You certainly can. I would not recommend it. I would recommend being specific, because chances are you do not need every single metric collected by that exporter. Do you really need to know the Go version where the value of that metric is always going to be 1 and you're just looking at the labels? Probably not. But what we can do is we can specify the metrics that we want to collect by name. We can also make sure that we're only collecting histograms or distributions where it's applicable and making sure that it's actually valuable. But then we can also do label exclusions. So even if our exporter did look like this, where we had a request ID and a user ID in there, we could instruct the Datadog agent to ignore those labels so they don't become tags. We may also want to refactor our exporter to not include the order ID in the route, but that's a little bit outside of the bounds of what we could do here. So there are ways to still do this safely. All right, so everybody shake it off for a second. Let's talk about when we should use custom metrics, and we'll stop trying to scare people. So first of all, think about your metrics. If you collect this data, how is it going to be used? Do we actually have a good reason to collect this data besides it being there? I would generally recommend that if we don't actually need data, don't collect it. There's not really a reason to if you're not going to use it. And if you do need it in the future, you could always start collecting it in the future. So we don't need to collect it just because it's there. If we're going to start collecting something new, what are we actually going to do with it? What story does it tell? Can we accurately represent what this data is trying to say in a dashboard? Will it make a meaningful monitor? Will it help me generate a report for my team and my boss? All right, so think about that. And then the other thing to consider is there data that solves this. If we have, going back to the logs example, if we have numeric facets in logs and our logs are processed well, we can represent those in a time series just through a logs query. Or do we need to collect an HTTP type metric if we have traces with metrics that show that at full granularity to begin with? Secondly, check if an integration exists before you start collecting data from it kind of arbitrarily. So like a good example here that I've seen pretty frequently are things like cube state metrics and the node exporter, which come with pretty much every distribution of Kubernetes at this point. First of all, these are built in. Don't collect them with open metrics, because then they will become custom. The Datadog agent distributions, whether it's through the operator or through the Helm chart for Kubernetes, come with cube state metrics themselves, and they will automatically collect it for you. And then the node exporter is really just doing what the agent does already. It's system resource utilization. So make sure that if there's data that you think you want to collect through one of these integrations, make sure that it's not already provided in another way that is native and out of the box. And then lastly, start small. So if you're thinking about using a custom database query, make sure that, first of all, run that query without the agent first to make sure that you're collecting the data properly and that it makes sense. And again, you go back to the first point, think about your data. If I collect this, how will it be used? But make sure you're taking a look at the results. And something to consider is during this process, the development side of things, consider adding like a select top 10 or limit 10 or whatever your database query language is, but just limit it down to a certain set of rows so you can make sure that as the data is coming in, that we can validate that we haven't done anything crazy. And if we accidentally did, the impact is going to be super minimal, because you can always then remove that limit later on the line once you're confident that you've done the right thing. And then if you're doing instrumentation of your code base, Tracing doesn't cover everything. So if you wanted to instrument specific functions that you think may be expensive or wanted some additional insight into business logic, visibility, and that sort of thing, just start small and instrument a small number of functions. You definitely want to make sure you have a solid pattern in your code base, because anyone on the webinar right now who is a developer, has written code before, we know that as soon as one pattern makes it out into production, people will probably latch onto that, even if it's a bad pattern, because it already exists. So make sure that you do have a solid pattern in your code base by testing, and then you can always instrument more functions later down the line. Just like regular iterative development, iterate on what you're doing when you're creating custom metrics to make sure that you do have that value present. All right, so it's enough of me talking. I'm going to pass it over to Kevin here. He's going to open up a Datadog demo. And Kevin, I'm going to stop sharing my screen and you can take it away from here.
Awesome. Thanks, Nick. Share here. Let me just get confirmation that you can see.
Yep.
Awesome. Cool. So before I begin, just to give a little bit of background on how I've seen this, Datadog product evolve. 4 years ago, when I was helping customers dive into, exploded unexpected costs of custom metrics, it was much, much harder, right? So we had some scary, at least scary to me, slides and information from Nick. But luckily now this product is in a place where it's much easier to kind of find out where those costs are coming from, where those metrics are kind of, causing the costs. So if anyone has been in the custom metric space for a while, you've seen this product evolve like I have, and I've probably grown in happiness as it's evolved. If you haven't, or you're brand new to custom metrics, this is a good time to be hopping in. Much robust product.
It was an equally happy and sad day when I retired my code that used to do this calculation when this page came out.
Yeah, I wish I knew you back then. I would have asked you for that code. Yeah, it would have saved me a lot of time in my position. But let's kick it off here. So to start, we're going to be taking a look at the metrics volume overview page. So a few things I'll go over here. At the top, these are going to be two important time series graphs that you can see. What you're seeing here is the separation of index custom metrics and ingested custom metrics. If you're familiar with our logging product, it works the same way. So you can kind of ingest all those metrics with all the tags. And then once inside the Datadog platform, if you decide that we don't need this tag, it's causing a lot of unexpected costs and it's not being used in our dashboards, you can use allow lists, block lists to kind of remove those tags or keep only the ones you really, really need. I'll dive into that a little bit deeper and how we can actually do that. But I like to call out those two graphs up top here are kind of showing the differences between those ingested versus indexed. On the left here, if you're familiar with Datadog, a lot of filtering options that we see across the platform, but a few things I want to call out. Query activity. So if you're looking to kind of clean up your metrics and maybe there's some metrics that were used 2 years ago, but they don't really apply anymore, but they're still being submitted, you can kind of look for the query activity. So if it hasn't been queried in 90 days, meaning that custom metric isn't being used on dashboards, notebooks, etc., that might be something you can kind of work to go through your code base and clean up, right? That's going to be a cost that you can save there. Not being used in 90 days, probably pretty safe to kind of, get rid of it or at least think about getting rid of it. Again, a little bit below, we have related assets. So if that custom metric is actually being used in some sort of asset, dashboard, notebook, SLOs, monitors, you can select that. Or if it's not being used in any asset, you can also select and filter by that as well. Metric type, Nick was talking about these if you're interested in different types. And then we have the metric origin. So either this metric is originating from a internal Datadog product, or whether it's coming from DogStatsD, you can kind of filter down there as well. So now the kind of the beefy part of this page here is we have this list of all of our metrics that are being submitted, metric name, when it was first submitted, and then you kind of get this broken down into the estimated ingested and estimated index custom metrics here finally, we have that change in volume. Right now, we're sorted by metric name. If I was, if I had my boss asking me to kind of do some auditing of our custom metrics, right? Let's see what's costing us the most money. I'm going to come to this page. I'm going to sort by estimated custom metrics here. And now that we can see in descending order, the metrics that are responsible for the largest amount of custom metrics. So at the top here, obviously we can see two that are probably the culprits of a large cost, right? 1,500, and then the third highest is going to be 99. These are going to be the ones I want to target and kind of look into a little bit deeper here. So if we click this, it's going to bring up our metric summary here. I'm going to kind of pivot a little bit and then I'll come back to this. So based off of what we're seeing here, we have 1,500 custom metrics. Let's go to the metric explorer, see what we have here. And now we're looking at the actual metric itself, right? So to me, this looks like a healthy time series graph. This is probably going to give us actually is going to be giving us the login success count of all of our users on our application. If we come back here, we look at the same metric. We can get a little bit more information here. So as it loads, we have some metadata here. This is important right here. So Nick mentioned DogStatsD. We can see that this metric is actually originating from DogStatsD. This is huge to me from my previous experience. This was almost impossible to track down to someone that wasn't familiar with their code base or new to the company and didn't know exactly where their metric was originating from. This would save me 3 days of investigation. So, you can come here, you can easily see where this metric is originating from, so you don't have to kind of go through your entire company trying to figure that out. Now below here, this is going to be kind of our important part, right? We have our metric. We understand that there's a lot of tags that are attached to this metric. So we want to find out which ones are going to be the culprits for making that number so large here. Looking through this, 1s, 2s, nothing really standing out here. 3, still nothing really. Again, not much. Page 4, this is where you scream. So, similar to what Nick was mentioning, we have the user ID, essentially, could be infinite if your application is large enough. And we have the user IP address as well. So just under, 300,000 IP addresses. This is going to be our culprit, right? So now that we kind of know that we have these two tags, user ID 200, that's not the worst I've ever seen, right? That's probably pretty normal with a basic custom metric. This one is going to be the danger zone. So let's take an example or take a look at what this actually looks like on the Metric Explorer page. So we'll go back, right now we're not aggregated by anything, but let's take a look at what happens to this graph once we're actually trying to use it. Nick, what does this mean to you? What is this graph showing you?
Absolutely nothing.
Exactly. I think we were talking, this could be considered art, and I was exploring a little bit. And if you switch to areas, this could hang up on my wall here, right? This gives me no useful information. It looks more like a Picasso piece than a custom metric, right?
It's like a paper cup from the 90s.
Exactly, right. Throwback to the 90s there. So we know that we could probably get rid of this, right? It's not giving us any useful information. It's only really giving us a cost that's unnecessary here. So now we switch over back to the metric summary page. So same page we were looking at. We've kind of figured out which tag we want to get rid of. That's going to bring us to this metrics without limits. So I click on manage tags here. And this is going to bring up our ability to configure our tags. So by default, we're allowing all tags. That's going to give us that current volume of 1,500 indexed custom metrics. Now, let's say we want to exclude those tags. So we're going to block list specific tags. From here, we can come in. We know that that user IP address is going to be that tag that is not useful for us. We don't need to keep it. And you'll notice when I click this, that estimated new volume dropped by 1,300. So we went from 1,500 metrics to 216. I can't do the math in my head, but I can guarantee you that is a pretty decent cost savings just by removing one single tag. Say we're also, we don't actually need that user ID. You can come down, add that to the block list. We're now at 2 indexed custom metrics. So that's obviously a very significant drop there. You can save this. That's going to save that block list. So those 2 tags are not going to be actually indexed anymore going forward. Same thing if you have a lot of tags that aren't necessary but are being submitted and you only really want to include a couple rather than exclude, you can do the same thing by selecting include. You can come here, let's say we only want cluster name. So now we're only going to be indexing that cluster name tag. So 2 separate ways that each kind of have their own pros and cons. Seen both used just as frequently, but very, very powerful and can save you a lot of time. If you don't have the bandwidth, you don't have the ability to find this tag in your code right away, come here, use the metrics without limits, configure those tags, include them, exclude them, and you can get those savings right out of there. Okay, so Nick gave a little bit of an intro to it, but let's say that these tags are actually kind of useful to our business. We want to have some sort of ability to track a user ID, track a user IP address. What are the best options outside of a custom metric? What's going to be cheaper to us? That leads me to the next segment here, which is going to be inside our log explorer. So one of the best alternatives here, if you do need to keep one of those tags, is submitting it via a tag or a log, excuse me. So instead of submitting those tags via those custom metrics, we're going to use a tag, or sorry, a log. So I'm in my demo account, so I don't have the exact same tag here, but you'll notice up here, we're going to be using customer.ip address. Let's assume that I set up my logging to submit this same exact tag that was found on the custom metric. Now that we have our log submitting this, we can find that in the logs and do what we need inside the logs instead of custom metrics. So for example, right now I'm showing count of all the logs by all the IP addresses. We'll click this top one. We can view the logs. We have 2 logs that have this attribute. Click this first one. We can scroll down and we see this customer IP address here. So, very easy to get, alternative method to submitting a tag that might be needed, but might be, costly in a custom metric. Instead, we can use a log to submit that same exact tag. One pro to doing it this way is then you also get, correlation. So up here, we can see that we have a trace correlated with this log. So we can click this. And now we're actually looking at APM in our flame graph, and we can track that log all the way to our trace, get information that way. Whereas you use that in the custom metric, it might not be as correlated or even correlated as you can see with this log to trace here. So pros and cons to both methods, but it's, seeing this should kind of spark that, ability to take a look and think about which way you can submit those tags. So let me scroll up here. Lastly, so let's say we've kind of, been assigned a project from our boss. We want to be a little bit more proactive about avoiding custom metric overage or spikes in costs in the future, rather than being reactive going into the past after you've been billed, X amount. What we'll do here is set up a simple monitor, right? We have our monitor page here, lots of options, but for this, we're going to use that anomaly monitor. So one of our 3 out-of-the-box machine learning monitors that'll kind of do the work for you, right? So we'll click anomaly. And if you're unfamiliar with anomaly, essentially this is going to take your metric. It's going to kind of learn the typical movement and pattern of that metric over time. So you can see up here, like, we typically have spikes and troughs in this metric that we're looking at. What the evaluation will do is understand that this is typical, right? If we were to see a huge spike here, then we would be alerted on it. So knowing that, we can use our Datadog estimated usage .metrics.custom metric right here. And that's going to be showing that estimated usage of our metrics that count over time. So up here, we can see it's pretty normal. Right now, I don't have any spikes, which is good. You can change the evaluation and how strict it's going to be. So if you want to be really strict, I would say this is probably pretty strict. These red bounds probably don't need to be investigated, but that could be determined by your team. If I scroll out here, zoom out here a little bit, this is maybe something we want to be alerted on, right? So typically we're about around 4.3K, and this spike is 5K. Maybe not, super unexpected, but depending on how you want to be alerted, you can set that anomaly detection, save this monitor, and then you can kind of forget about it. If anything out of the ordinary happens, if something like an open metrics configuration is changed to include that dot star, then you're going to be alerted immediately as 100,000 metrics in flux. So that kind of wraps up my portion of the demo. I can pass it back to Jess. I think we have some Q&A and we can wrap it up.
All right, awesome. Thank you both so much. One question that came in, I just wanted to address to everybody first is, yes, we will be sending out a link to the recording either later today or tomorrow. So everybody will get a copy of the recording and a copy of the slideware. So that's that. Okay. Nick, let's see.
I think we've got a few questions in here.
We do. Which one do you want to tackle first?
Yeah, so a few of these we kind of already covered, but I definitely don't want to just leave people hanging, so we can address them a little bit more explicitly. The first one is, does Datadog tags have the same cardinality, performance, and storage cost issues like Prometheus labels? So the good news about that is the issue here is really cardinality and cost. Performance and storage is abstracted away from you as a Datadog user, since Datadog is a fully hosted SaaS product. Does it? Probably. Is it something that you have to worry about? No. Again, the only thing that you would have to worry about is how the cardinality of those metrics, because the storage cost does kind of wind up being offloaded onto you as a result of utilizing custom metrics. But it's not going to affect performance at all. You can still query and split by an extremely high cardinality metric. So like Kevin showed, those metrics still load quickly. You can still load months worth of data at full granularity for all of those. So it's definitely not a performance concern. No. There's another question around, is there a way to find all the active custom metrics? So Kevin did just go through that in the volume page, and just like he sorted by the estimated number of metrics, you can also sort by the estimated, the time that it was first submitted. So the other part of that question, says we usually forget about old metrics. So you can say that, it was first submitted 2 years ago and it has a cardinality or a custom metric number of X. So yes, you can use it defined that way. So let's see. Kevin, there's a question in here that I think you might want to answer, since you kind of just touched on this a little bit. So logs are kept for a limited amount of time. How can we have a larger historical data set without using custom metrics?
Yeah, that's a great question. So you can actually you can use that attribute that I had and turn it into a custom metric itself. There's also, different ways to extend the retention of logs as well. I think I'm forgetting one of the ways.
I think the one, yeah, I think the thing that I would consider here is like I also said during my portion of things is we're not telling everyone to not create custom metrics. But one thing that we can take a look through within this page that Kevin was showing a moment ago is when we look at our tags here and we see that we have user IP address, what we can also see is where these resources are used. And I think there's one that is used somewhere. I could probably just do this the easy way where I select used in assets. There we go. So this is a low cardinality one, but just for sake of example, we can see that in this dashboard, none of these tags are actually used. This is just put on here as a flat metric. If we look at something like this, we can see that in this metric that on this dashboard, we are looking at the tag of has purchased, and we are looking at the details of device category. So one thing that you may want to consider, and the reason I'm showing this is that we don't need a huge amount of facets to make a large amount of custom metrics to present the data that we're looking to create. If we do create a custom metric based off of log data, what's really important is that you're creating that custom metric with only the tag breakdowns that you really need to present the data that you're looking for. So if you do create custom metrics based off of logs, the retention period for that is 15 months, just like any other regular metric. So even once the log expires, even if it's in a 3-day index, those metrics will still be kept around for that full retention period. How far back in time can an anomaly monitor look back? If we have yearly seasonality that we need to keep track of, can it look back that far in time? Kevin, I don't have creation access in this account. Would you mind pulling up the anomaly monitor again real quick?
On it right now. Okay, so here's our monitor. This is kind of going to be the portion you would be interested in, right? So I think by default, we're evaluating bounds for the last 15 minutes. But if I click this, I can actually scroll down. There was a custom. Okay, so we can change it by weeks here, right? So if you wanted to do, I don't know how many weeks.
52 weeks.
Thank you.
Yeah.
So now we're looking at 52 weeks, and this is going to be that yearly seasonality, or whatever time frame you might need. It can be adjusted to whatever custom time frame you need here. Cool.
Let's see. Why is this an opt-out for each metric and not an opt-in for the metrics I want/need? We are constantly chasing Datadog averages for custom metrics, of which we only use a few. Kevin, do you want to take that one?
Yeah, so when you mention opt-out, what are we referring to here?
Yeah, I think that's it's just saying it's an opt-out for each metrics and not an opt-in. I think maybe it's because we just took a look at exclude instead of include. There are a few options on the metrics without limit side of things that may answer the question.
Yeah, so let me pull it up again. Go back to metric summary. So for this, I guess to answer this question, assuming you are referring to kind of this configuring tag here, allow all tags is going to be the default, just because typically, I guess maybe it's expected that all tags that you're submitting from a dogstats.d code base they're going to be expected. So maybe that's kind of why this is the default. And then the include exclude tag kind of both have their pros and cons. Like I mentioned, include tags is probably going to be useful only when you have a very significant list of tags, and let's say you only want to include one, instead of going through and excluding 300 different tag keys, right? Whereas you can use the exclude if you have those 300 tag keys, but you only want to get rid of the two, like I had an example, you would just use these. Both are going to give you the same result. I think this is probably a matter of saving time and kind of quality of life options here. But yeah, these are both have kind of had their pros and cons there.
Cool. If I have a set of logs that I want to make custom metrics out of, are there any requirements before I create custom metrics off these logs? Yes and no. So I say no, because if you're just trying to do a full text query that says like, order completed or something like that, and all you need is a count, then you can do that right off the bat. However, if you need other kind of faceted information or numeric information or other facets like query strings or URIs or something like that, you would need to make sure that your logs are processed through Datadog pipelines appropriately to make sure those field names are broken down and available. Otherwise, we won't be able to craft a query that we can actually create a metric off of with different dimensions. So you do need to do some additional processing of those logs into a format that can be used to create metrics off of. Let's see, I think we've got time for one more here.
I'm happy to take this last one here.
Yeah, good.
So this question is, what are the options to reduce the noise on anomaly detection monitors? So you can see on my screen here, I went back to the anomaly monitor. I opened up the advanced options here. And now we can have the option to kind of adjust the algorithm that's being used. So there's a whole documentation page that goes over the different types of algorithms, but essentially you can change the number of deviations here, 1 to 5, and then we have a basic algo, agile, and robust. So again, happy to follow up with documentation on each of these, or you can find them pretty easily on your own on the monitor documentation. But these are going to kind of adjust how the algorithm is looking at your metric itself. So pretty robust ability to change how the algorithm is detecting those anomalies, but definitely doable here under that advanced options.
Yeah, and I think when it comes to things that may incur a high cost, it's always better to have them be a little bit noisy and check in on them and then tune them down rather than trying to have them be quiet at first too much and causing yourself to miss certain things. So as much as nobody wants to receive any alerts, when it comes to cost type stuff, I would always rather over alert and tune than under alert and have to be the one that pulls the credit card out. Cool. All right, let me reshare this last slide here.
Great, thank you. Okay, before everybody goes, just really quick, let's take a look at some upcoming things to be on the lookout for. Next week, we are dropping the first episode of what we're calling Shop Talk. It's filmed actually right in Nick's workshop. Nick is literally turning blocks of wood into something really beautiful and special while breaking down Datadog concepts at the same time. It's really cool. You'll want to check it out. Then we are all going to be at AWS reInvent the first week of December. So if you happen to be there, you're planning on going, and you want to pre-book a meeting with Nick or the rest of the team, you can grab that QR code in the middle there. And the last thing here is wrapping up the year. We're going to be hosting a live virtual NoBS office hour. It's 1 hour. There's no agenda. You can just show up. Nick and the rest of the engineers will be on, and we'll be taking real questions live. Should be pretty interesting. You can register on our website on the events section. So with that, thank you both to our presenters and everybody who joined us today. Huge thanks for spending the time with us. We hope it was really of good use. Take care, and if you need any help, feel free to reach out.
Thanks, everyone.
Ready?
Yeah.